Hi, welcome to PyTorch Perry. This is a YouTube account where I teach PyTorch. This is for people that just, you know, learn PyTorch basics, make models, all that. And yeah, if you're looking into machine learning, this is a great account for you. My name is Perry. I'm gonna be the one helping you learn PyTorch today. I want to say before we get started, before we build our first PyTorch model, I want to say that this notebook I'm going to be making in Google Colab, which is our coding environment, is is based off of Daniel Bourke's 25-hour PyTorch tutorial. I learned everything from him. Everything. Like mostly everything. I'm still learning PyTorch. I'm not the best at it, but I know how to, explain a simple model, which I'm going to be doing today is a linear regression model. And yeah, I just want to I'll leave his link in the comments down in the description below. You guys go check him out. He'll explain, if you can't understand from me, he'll explain it way better than I can do. Like I said, this notebook is basically based off of his, but with just different inputs. So yeah, without further ado, yeah, let's get into it. So today if you haven't made a PyTorch model yet, it will be your first one. It's going to be a very simple model. We're going to be making a linear regression model. So I have my Google Colab over here. Linear regression. I'm going to be running this on the CPU. Let me just make sure if it is on the CPU, because we don't need the GPU. It's going to be very simple computations. It's not going to be numerous computations. So I'll just be using the CPU for this. It's up to you what you want to use. I recommend CPU because it won't take much time when it's training. But it's up to you. But yeah, let's get in. So first I want to define, I'm going to write this first, then you guys can, and I'll explain after I write it because you guys don't know what I'm writing right now. So right over here, I'm creating a tensor that starts at 0 and ends at 1 with a step of 0.02. So this will give us a tensor of size 50. And I'm squeezing the dimensions. I'm squeezing it. And I'm making, so yeah, I'll explain right over here. So I over here weight and bias, and I'll get what we'll get into what these mean, what those terms mean in a minute. But over here, a linear regression model, right? Mx plus b. M is slope, b is a y-intercept. That's what we were creating here. Weight is m, and bias is b. So what the whole point of this, model is, and I'll visualize it. And oh wait, I forgot. We need to import the most. We can't do anything. This is the whole point of the course, we need to import torch. And not only that, I need to import a visualization library, and we're going to use, also we need from torch, import nn, and then import, we're going to use matplotlib pyplot. Alright, so let's run that real quick. Alright, downloaded that. Alright, so we come back to here. So what I did here is I created a tensor of size 50 that starts from 0 and goes up to 1 by steps of 0.02, so that's hence why it's 50. And then over here I have a y. This is a tensor that is just applying the weight and bias to the x. So if you look over here, if you want to look at the first 5 values of x. Sorry, I'm very bad at typing today. I don't know why. Maybe I'm just nervous. It's my first video. Alright, so if you want to look here. So over here first, so we have 0.0, 0.02, 0.04, 0.06, and 0.08, and the corresponding y values. So 0.4, 0.412, 0.42, 0, etc. Right? So now, oh yeah, and let me just show you that they each equal 50. 50 x values, 50 y values. And now we want to split these into training and testing. Training, testing, So we want to create splits. We have a training coordinates, x coordinates, and we want x coordinates and y coordinates, and we have testing x coordinates and y coordinates. So we're gonna split these, right? So generally, training is the one that we train on, obviously, and testing is the one that we test on, unseen data, right? So for training, it's generally for this model we're gonna use a 80% 20% split. So 80% of the x coordinates will be towards training, and 20% of the coordinates will be towards testing. That's how it is generally, a training testing split. There's also a validation folder as well, but like for this we won't use it. I'm not very experienced with validation, but in every machine learning model, every workflow, you will see a testing and training directory. So we're gonna create a training and testing set. So we're gonna train split. So we want the 80% of the coordinates. So that's gonna be 40, right? Because 80% of 50 is 40. So we're gonna create a split integer here, which is just 0.8 times the length of x, which is that's 50. Now we're gonna create our sets. So x train split. This goes up to 40. This is gonna get the 40 values. Oh, x and y. Sorry, this is gonna be train. Oh, sorry, this is gonna, yeah, so it's gonna be here, and then x test, y test. This is gonna be everything past train split, right? So this is gonna give us the last 10 values. Sorry, I'm not typing good today. Sorry about that, y'all. So over here we did it. Oh, sorry, it's everything after. What am I doing? That'll just give us the first 40 again. Alright, we created that. And now to show you the length of each, which is, you guys can guess right now, it's gonna, I said it already, but it's gonna be, as you'll see in a minute when I'm done typing. Oh, I put, okay, I'm tripping, man. Alright, because I put 0.5. Alright, 40, 40, 10, 10. Okay, it's like, what the heck, where did 25 come from? Yeah, so it's gonna be 40, 40, 10, 10. So 40, 40 x coordinates, 40 y coordinates dedicated towards our training sets, and 10 x coordinates and 10 y coordinates, in relation. That's going towards our testing sets. So there we go. So now I want to visualize. This is where our matplotlib PyPlot is going to come into play. I just want you to visualize this equation. This equation we have right here, right? This is a simple linear mx plus b, right? That's what we're trying to that's what we made over here. So I'm gonna make a function that plots predictions. So train data is equal to x train. I'm hard coding this. Train labels is equal to y train. Test data is equal to x test, and test labels is equal to y test, and then prediction is equal to none right now, because we just want to visualize this over here. We have no predictions yet. So we're gonna make a PLT figure of this fig size of 10, 7. Oh, create the equal. PLT the scatter. We're gonna put this in blue. Train data. Train labels. Labels are the x values. So yeah, let me say that I should, bring up that concept that we call is ground truth labels. Like what we were trying to predict, the value that we want to get, compare it to, that we want to predict the accurate results, where we're comparing it to. That's the labels, right? We want the correct label for the model, right? Ground truth, everything. We're comparing it to the ground truth, but we want the correct label, right? We want the correct label. So yeah, so we just want it to match the ground truth in other words. So yeah, so that's the y coordinates in this case, right? We want to predict the correct y coordinate, and then you'll see in a minute what the weights and bias mean. It'll all make sense. Sorry if I'm not making sense, but you'll see in a minute. I'm just gonna be over here finishing and title this training data. Alright, then we're gonna make another scatter, this time with test data, and we're gonna label this, we're gonna do green, yeah. S equals 4, label equals testing data. We're making this a function because we're gonna use it later on, so it'll be easier. I mean, you don't have to write it all the time. So predictions is not none. plt.scatter test data. This is if it's none. Predictions. Predictions will be our predicted y values. You'll see how the model, or once we create our models, you'll see what I'm talking about. Then s equals 4, label equal predictions. Okay, and then I'm gonna show the legend. Bro, I've never coded this so slow. Alright, there's our function. Let's plot. We already hard coded it, so, and we have no predictions, so it's gonna be none. So it's gonna skip that part in the function. Alright, here we go. So here we go. Okay, beautiful. So here we have our x coordinates, right? And then our y coordinates. So these blue points are representing the x and y coordinates in the training set, right? The 40 coordinates. So these are 40 coordinates, right? Because we had 40, we split it 80-20%, right? That resulted in 40 coordinates. So over here we have the 40 coordinates, and then the testing, the last 10 coordinates of the x and y set, right? And we have this in our testing set, right? The green. So what the whole point is that we're going to create a model, right? And these model at first is going to give us completely random weights and bias, right? Weights and bias are the parameters of a model, and the whole point of these parameters are they need to be, that's the whole point. That's how all neural networks work, right? They all create weights and bias, and the whole point of these is that every time you put your input data in tensor format, they're going to perform mathematical operations. I don't know what goes behind the scenes with the weights and bias, and they're going to give an output. We want to adjust these weights and bias so we get the correct output. That's the whole point, and that's where all the optimizer does that, backpropagation, gradient, all that. That's where it comes to play. But we'll get to that in a minute. Let's not get too far ahead of ourselves. I was actually, but let's first let's actually just create the model. So from Torch, we want to import NN. And we're going to create a linear regression model. So class and everything in PyTorch, almost everything, like mostly everything, inherits from the nm.module. That's where it gets these you can create such building blocks in neural network. So def so we're gonna create a weight, just a weight. Sorry, I'm not gonna. So where's a weight? That's gonna be your parameter, right? And you'll see how it matches with the weight and bias we created beforehand. So torch.rand. This is just me a random number. Requires gradient true. We're gonna need gradients. And we want it on the correct data type. We put into torch.float. And then we're gonna create a bias, which is gonna be another parameter. And this is also gonna be a random value. Did I? Yeah, I didn't put a none in there. Dude, I've never been this bad. Sorry guys, I'm probably just nervous. Yeah, I've never like walked through like made a video explaining because it's my first time. So hopefully I'm gonna do better next time. Let me know in the comments what you guys want me to improve on, please. I need the feedback if I'm gonna continue further making videos because I want you guys to understand, right? That's the whole point of this channel. I want you guys to learn PyTorch, you know, and apply it to whatever you're doing. So please let me know in the comments. But yeah, now we're gonna create the format. You need to overwrite the format when you're inheriting from nn.mod. You always need to overwrite the format. This is gonna give you the predictions. Just forward method exactly. So over here, this is gonna return a tensor. So what do we want? Return self dot weight dot x. So it's gonna use these weights. Sorry, it's not weights. Wait. Dot x plus self dot bias. So now, here, let me just quickly run this off, and then I'm gonna create an instance of this, right? I'm gonna create a quick instance. This is gonna be model. I'm just gonna call it model. Regression model. So here's our model. Now if you want to look at the dictionary, this doesn't show the weights and bias that it created. The weight and bias, it's just one way. You know, like when you get into more advanced, this is just a simple linear regression model, right? When you get into most advanced models, there's gonna be a lot of parameters, like a lot of weights and bias. It just gets, that's way more advanced. But for the purpose of just teaching you, making your first model, we're gonna start simple, of course. You gotta start simple, right? So you want to look at the sorry, it's not model 0. Weight is, this is what it created a negative. So the whole point, okay, so this is what's gonna happen. You see this weight and bias? We want it to match what we made over here. That's what we're trying to do. Because when we match this, it's gonna perform the correct operations to get the y value, right? On the x value to get so once we put x into the forward, it's not gonna get the right y value. So that's the whole point of machine learning. It looks at these and then, you know, performs a series of functions to change these weights, right? Eventually changes these weights. So once you forward it with the, you know, with these x values, it's going to correctly predict the y value. That's the whole point, right? So that's the purpose of weights and bias. We're trying to correctly match so we can get the correct predictions. All right. So let's actually make predictions with this model. So this is not dummy data, but just, you know, just to see what, like, how it's working. So you see right here, we're gonna put the x testing data. This will actually be a part of the training set, but like, it'll obviously get better. But this is just us putting in points right now and seeing what it outputs. So if I want to see what y-pres looks like, that's what it looks like. Yeah. And if you want to look at the actual values, which is going to be y-test, what we're going to compare this to, this is when we see how far off these need to match, right? And based on that, the weights and bias are going to update, right? On what we train on. It's not going to train on the testing. It's not going to train off this. But once we're done training, and if we train correctly and it's giving good accuracy, low loss in the training, it'll correctly, when you put the x test in, it'll give the correct y-pres. It'll match. These two will match. So whenever let's just make predictions now. So let's make predictions. So let's make predictions now, right? So whenever we're making predictions with the model, we need to go first. We need to go into eval mode, right? Model.eval. When we're training, it goes into training, but when we're predicting, we gotta go into eval. Evaluation. Then we're gonna put with torch.inference mode. We're gonna make our predictions. Y-pres is gonna be equal to model x test, and then we put the y parets and the y test. So we need these y coordinates to match these y coordinates, and if you want to plot it to see it visually, now we're going to use predictions variable. Y parets is, oh, did I, oh, there's 2 underscores. Well, that's not right. What did we do wrong? Oh, I created this to a 4. Oh my god. What color should this be? What color should I make it? Let's make it yellow. I think I like yellow. Oh, you see, we don't like this. We don't like this. We want this here, right? Here's vision. So we're gonna update the weights and the bias to this set of points. Get over here. That's the whole purpose of machine learning. This is the whole purpose. It's quite fascinating. This is how, I'm not gonna, of course, how, this is just a very simple model, but this is how these fundamentals is basically how every neural network architecture works. Like a transformer, the transformer is monstrous though in the number of parameters. It has nothing compared to this, but it's essentially all the same. It uses the same principles, you know. You make your model, training, testing, you want to update the weights and bias to correctly predict the data better, but it's way more complex, obviously. But that's the whole, it has the same essence, right? So, without further ado, why don't we start making the training loop, alright? So, we need a loss and optimizer, right? So, we need a loss function, and we're going to use, since this is a linear problem, we're using linear regression, we're just going to use nn.one loss. When you get into binary classification, segmentation, multi classification problems, you know, you're going to use a different loss function, but since we're using a linear, we're just predicting linear values, we're going to use L1 loss, right? And then an optimizer for this is going to be torch.optim stochastic gradient descent. We're using stochastic same. So our optimizer is going to be we're using stochastic gradient descent, and we use stochastic gradient descent because we're calculating points on a line, a straight line. So this is going to have parameters. It's going to be model.odal. And a learning rate, this is very important. So a learning rate is possibly, it's a hyperparameter because you have to set it. It's one of them. It's probably the most important because this is how fast your model. Like, how do I put this in words? This is, yeah. If this is your model's learning rate, literally just, it's all dependent on that, right? If you have too big of a learning rate, it's gonna take bigger steps. So let me say this one. Let me explain before I get into that. Actually, let me explain what the loss function is. So a loss function is, you know, it's I don't know what the math is behind it, but it's provided by PyTorch nn.one loss. This is specifically for linear problems, right? And we have an optimizer, right? And then we use these for the purposes of backpropagation and gradient descent. So what backpropagation is? It calculates the gradient, and the gradient is a derivative on the, you know, on the loss function. And we want that, what gradient descent is we want to descend the gradient so it gets to a slope of 0 if I'm correct, because that would mean loss equals 0, right? Because since it's the derivative, since gradient's the derivative of the loss function, we want to get that gradient as close to 0 as possible. So that's why it's called gradient descent. We're descending down to a slope of 0. So that's where the learning rate is. It's how big of a step the gradients take. So if you take a big step, the gradients are, you know, it's not going to learn anything at all. It all depends on testing and trial and experimenting. But I always start off with the 0.01, or 0.001 is never hurts, right? Those are most common learning rates. But if it doesn't work, then you adjust it, however so. There's also another concept called scheduler, which can change the learning rate when you're training, but that's more of an advanced intermediate topic. But since the purpose, I'm just going to show you just the learning rate and make it stay constant. So yeah, that's what it is how small of a how big of a step are we taking. That's the point of the learning rate, right? So we just want that perfect spot, so we're taking the correct amount, the decent amount, so we're not overstepping, if that makes sense, right, when we're performing gradient descent. So our learning rate for this is going to be 0.01. We're going to start at that. Now let's make our training loop and our testing loop as well. So we're going to use let's do 100 epochs, since this is a very not many it's not going to take it's not many computations that are being calculated, right? So we're just going to do 100. It's going to be very fast, even on the CPU. So we're going to use these to track different values. So okay, so what the epoch is, it's gonna go 100 times. So we send epochs out. This is how many times are we retraining the model, essentially, right? How many times is it gonna go through the training loop? So we gotta put model into train mode, and ypred is gonna, now we're gonna make our predictions, right? Model 0, not 0, model X train. So I'll PQ him because I'm taking reference to Daniel Bourke's notebook. Like, please go check him out. He's probably explaining it way better than I am right now. But I'm just trying to put this in my own words, But big, really big. He's the one who inspired all this. So I can't thank him enough. So we're gonna get our pred. Now we're gonna use our loss function. We're gonna get a loss value from the loss function, while comparing the ypred to the actual y. Right? We're gonna get a loss value, and based on this loss value, first we gotta set the gradient to 0. That's very important. Optimize the 0 grad, right? And then after that, we're going to perform back propagation. This is where the gradients are going to be calculated, right? And then based off that, it's going to tell the model, hey, this is the step this is the direction you got to go to perform gradient descent. And then the optimizer is going to update its weight so it gets to that, so the gradients get so the loss becomes more and more 0. The gradient slope is becoming more and more towards 0. So now that we have our train loop, that's what it is. Now let's go, sorry, this is model 0. Let's make our testing loop. We're going to put this in a val. But torch.inference model, always important when you're making predictions and testing data. We're gonna update the values that we were tracking. Didn't make this correct. There we go. Test loss. That pen test loss. Oh, I didn't even. Alright, so. Alright, now we're gonna make our testing loop. So we gotta send it to evaluation. Always gotta do that when we're predicting on unseen data. Inference mode. We're gonna make predictions now using the X test set, right? So our test predictions is gonna be in the X test. Oh my god, I cannot. I'm typing way too fast. Maybe I should try typing slower so none of this, these errors pop up. Now, test loss is equal to loss function, then test spread compared to the actual values, right? and now I want, just for visual purpose, I want to print out what's going on when the training loop is going through all this, right? So every time the epoch number is a multiple of 10, I'm gonna print out what's going on. So first I'm gonna add it. I'm gonna update these tracking values. Now let's print out what epoch number we're on. Now, I also want to print what's going on with the weights and bias as we're training, because you'll see how they start to change and it's getting updated using optimizer.step, and how they get closer to the weight and bias we created, right? There we go. All right. Without further ado, let's run the model. Alright guys, sorry I was doing a little trouble, there was a problem going on, but let's run. I'm gonna do 200 epochs, so this is going very fast, so let's run it. So you see now, okay, there we go, because I think I had to run every cell again, there was something going on. But now you see, first of all, yeah, these are never supposed to show negative values in the first place. These positive, I should have caught on earlier. This is positive now, it was before negative. There was something wrong going on, I had to run this all over again. Maybe it just wasn't register some of the functions, or something was going on. Well, it's fixed now. Now we can see as our loss. So I train a lot. The loss doesn't start that low. It really never starts that low. But over here, you saw the test loss. It all goes down. And guess what? It went down to 0.00, 0.00. And look at our weight. Almost, basically 0.6 and 0.4. What was our weight and bias that we created? 0.6 and 0.4. Now, if we want to show this visually, first we're gonna first plot prediction. Oh, we gotta make predictions first with torch.inference mode. I forget. First, you gotta put a model.eval ypreds. Let's call it npreds, new preds. Ynpreds model x test. We're gonna show on the x test now. And there we go. Y plot predictions. Predictions is equal to y npreds. Look at that. Look how that's beautiful, isn't it? Machine learning. There you go. That's basically most of AI. That's how AI works. It's machine learning, deep learning. It's getting the loss values, optimizing, and yeah, weights get updated so it can accurately predict the data. So if you want to compare weights and bias side by side, so these are the weights and bias that we created, and this is the weight and bias that our model has now, after trained model has now. So there you go, almost identical basically there. And now that's the power of machine learning. And if yeah, that's really it. You guys just made your first PyTorch model. You guys should pat yourself on the back. It's a big milestone, right? If you created your first machine learning model, you should applaud yourself on the back for that. This is very creative yourself. A model where you predicted the correct Y points. That's really cool. So in my next videos, of course, I'm gonna go more advanced, like more advanced models, you know. And myself, I'm still learning PyTorch, as you can tell. I was unsure of this stuff, but I got the principles down. What you know, what the how machine learning works. But that I will get into more advanced models. But tell me how you liked it, and you know, correct me on some things. Tell me what I need to improve on. It's my first video explaining code ever, so please let me know. And yeah, that's it. Thank you guys for watching. I'll see you in the next one.